Okay, how's everybody? Good. I feel like I haven't seen you guys in quite a while, even though it was the other day. We just didn't do anything, I know. Okay, that time is actually coming, but we do have to finish up a few things before that. Okay, so you've already got focus activities 3 and 4. It has been a while since we've done one because we haven't really seen each other. There are copies of 3 and 4 over there in the files if you do need one. Nathan? Oh, I'll take a look at it when you turn it in. I'd have to look at the calendar. Okay, so you have number 5. I've got a number 6 for you. So on Wednesday of next week, that's when our focus activities will be due, 3, 4, 5, and 6. Probably on Monday or Tuesday, I'll give you 6, and we'll go from there. Okay, so let's see what it says. This is going back to sequences and series. It says find the sum of -6 plus 1 plus 8 plus 15 plus ... all the way to 141. Okay. All right. So how many formulas were there if it was a arithmetic sequence?
2.
Okay, 2. And is that what we're dealing with here? Well, let's see. How do I get from a -6 to a 1? Because remember, the pluses make it a series. The sequence was originally just -6, 1, 8, 15, ... all the way to 141. So it looks like the common difference is 7. So I'm just adding 7 over and over again. We can see that the very first term was -6. Okay, so the two formulas we were talking about, one had n divided by 2 times the sum of the first and the last. And the other one was n divided by 2 times double the first plus n minus 1 times d. Okay. So you'll notice we have the common difference. We have the first term, but in order to use either formula, we need what additional variable? We need n. We need to know the number of terms that we're adding up. Okay, so why don't we go ahead and do this? We'll come back to these formulas. Let's say a sub n is equal to the first plus n minus 1 times d. Now, all I know is that this term, 141, that would be the nth term, the last one. I just need to know what term number it is. So why don't we go ahead and plug everything in, and then we can solve for that. So let's see, the first is -6, plus I have no idea what n is. And we said d was 7? Okay. Now, because I'm trying to find that last term n, I'm going to go ahead and set this equal to 141. Okay. Is everybody okay with how I created the equation? So what do I do now? Okay, let's distribute that 7. So let's see here. 141 should equal -6. That would be plus 7n minus 7. So 141 equals 7n minus -6 minus 7. -13. And how would I get 7n by itself? Okay, so let's add 13. Okay, so it looks like we have 154 is equal to 7n. And then how would I find n? Divide by 7. All right. So come on over here. 154 divided by 7, 22. So there are 22 terms that I'm going to add here. Okay. Now, I already took the formulas off. Did you want to use the first one or the second one? You want to use the first one? The first one was the shorter of the two. So so in this case, I know n equals 22. So I'm going to say, let me write the formula again. The first plus the last. Okay. Well, n divided by 22, that would be 22 over 2 times the first term, -6, plus the last term, 141. And all we have to do is just simplify that. What is 22 divided by 2? 11. So let's see here. I'm going to say 11 times the sum of -6 plus 141. Okay, so I would say the sum of those 22 terms should be 1485. 1,485. That's a 5. I'll write that better. There we go. Okay, there we go. Okay, well, let's take a look at number 2. Now, we're already given n. What is that? Oh, no, that was n on number 1. What is the value of n? What's the number of terms on number 2? 12. I want to add up the first 12 terms. Is this arithmetic or geometric? Let's see. If I look at the sequence, it's 2, 6, 18, 54. So you're saying I'm multiplying, right? What am I multiplying by? 3. So my common ratio, r equals 3. We know the first term is 2. Okay. We know n is 12. All we have to do here is plug in. There is nothing we have to find. Okay, so the sum of a specific number of terms for a geometric, it was the first term times 1 minus r to the n all over 1 minus r. Okay, remember, all I'm going to do is just plug in. Okay, so that would be 2 times 1 minus r to the n, so that's 1 minus 3 to the what? Oh, to the 12. And then we're going to divide that by 1 minus r, so 1 minus 3. Okay. So this one was a lot faster than number 1. You just plug in and you'll get your answer. Or you could actually just list out the 12 terms and go ahead and add them up if you wanted to do that. Let's see here, control divide. So 2 parentheses, 1 minus 3 to the power of 12. Okay, let's get out of that. And then we're going to have 1 minus 3, or you can put in negative 2, whatever you like. So when I push enter, looks like I'm getting 531,440.
Yeah, oh, I got 441. Wait, what did I do wrong?
I don't know.
Oh, it's 1 times 3. Wait. Oh, yeah, I put 1 times 3.
Oh, you put 1 times 3? Okay, there we go. 531,440. So 531,440. There we go. Okay, so let's try number 3. So it says a geometric sequence has the first term 5, common ratio is 2. The sum of the first n terms of the sequence is 635. Find n.
Okay, so we know that r would be 2.
Okay, so let me go ahead and plug in here. So we have a sub 1, 1 minus r to the n over 1 minus r. Okay, so we know we're already given the sum. So I'm going to go ahead and say 635 equals. The first term is 5 times 1 minus, what was r? 2. You're right. Okay. To the n power divided by 1 minus 2. Okay. So all we have to do is work backwards and figure out what n is.
So we know that 1 minus 2 is negative 1, right?
Okay. So yeah, we could do this because this is just negative 1. If I were to multiply through by a negative 1, that would be negative 635 is equal to 5 times 1 minus 2 to the n. Then we go ahead and divide by 5. So that's negative, I have no idea what that is. 127? 127 equals 1 minus 2 to the n. Then you can subtract the 1. You're absolutely right. So if I subtract 1, that would be a negative 120 what? Ooh, 28, because they're both negative. Those cancel. Equal negative 2 to the n. Now, they're both negative, so you could simply make them both positive. Now, it's not a square root. Basically, we're wanting to figure out 2 to what power would give me 128. Now, normally, what kind of problem would we use to solve this? Starts with an L. Not linear. Log. It will be a logarithm. But we probably don't need to do that here. Remember, n, we're looking for the term number, so there's no fractions, no decimals. So, does anybody happen to know 2 to what power will give me 128?
It's going to be
Let's try one. 2 to the 9th?
No.
512. So a little high.
2 to the 10th. No, wait,
Well, see, if the 9 gave me 512, so we want to go down. So 2 to the power of 7, 128. There we go.
Okay.
So how many terms did we add up to get 635? There would be 7. I like that. We got 512. 11! Go higher. All right, so questions. How are we doing? All right, good. Okay, so put that someplace safe. Right now you've got 3 and 4. You have 5. We'll get 6 next week. Scroll down. Yes, ma'am. We'll get 6 next week. And then remember, this is one of the final grades. It should be a guaranteed 100, especially for the seniors, okay? This is not the final. In fact, I put your final together earlier today. Actually, here's what I'm going to do. The final has 10 multiple choice questions. What I'm going to do, I gave you a review with the exact same questions. 10 and 10. It's not like in Christmas where I gave you like 21 questions and you only had 10 out of the final. I'm going to give you a review with the actual final questions. So all you have to do is look at it and solve the problems. You got the final taken care of. I just won't be able to help you with that. So we could probably, have one of those class periods where somebody will come up to the board and you guys can work together, but the review is your final. Okay. The review in here is your final exam. It is multiple choice, the exact same questions and answers. So all you got to do is solve the review and you should be good to go. Can't be any easier than that. Okay. All right. Well, let's talk about Pascal's triangle. Okay. This is something we were doing the other day. I believe we got to an example. Okay. We got to several examples. Here we go. So why don't we just go ahead and get right back into it. Let's kind of see what we're looking at. But Pascal's triangle, how did I generate the numbers, the rows here?
It's like 1 times 4, 1 plus 6, 3, 2 plus.
There you go. You add the numbers directly above to get the number below. So the first number, the 1, always drops. Like 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1, 4, and then the 1 drops. And then you just continually build off of itself. Now, when you're counting the number of rows, you always have to start with what? You always have to start with 0. Yes. 0, and then 1, 2, 3, and so on. The power you're raising your binomial to is going to be the row number that you look at. Okay, so let's do a quick review problem before we get back into it. What we've typically been using is A and B. So let's say A plus B cubed. Now this is one that we actually solved by hand previously, but because I'm raising this to the 3rd power, what row of the triangle will I look at? The 3rd row. So the 3rd row is right here. You'll notice we have the coefficients 1, 3, 3, and 1. Okay. So I'm going to come on over here. I'm going to put 1, 3, 3, 1. Now why did I leave so much space between them? There you go. We have to put in the first term and the second term, which we refer to as A and B. So each one of these is going to have an A-B combination with it. Okay. Now remember some of the patterns we were looking at the last time we talked. The number of terms in your answer is always 1 more than the power you're raising your binomial to. I want this to the 3rd power, so I have 4 terms. Okay. Now, what did the first term's power do? Did it increase or decrease? It always decreased. So if I want to start with 3, this would be 3, 2, 1, 0. Who has the answer sheet? Okay, Kirsten has that. And the B's do what again? Now the A's decrease while the B's increase. So I'm going to start at 0 and go 1, 2, 3. And you'll notice if you look at the powers on each term, the sum is always going to be the power that you're placing on your binomial. Okay? So 3 plus 0 is 3, 2 plus 1, okay? Keeps going. And then now we simplify. But what's anything to the 0 power? That's just 1. So this first term, 1 times a cubed times 1, well, that's just a cubed. Plus 3a squared b plus 3ab squared plus, looks like 1 times b cubed. There you go. That's what this triangle is allowing me to do. Very quickly, in seconds, I can write out the full expansion. I don't have to perform all that algebra. Very little chance of my making a mistake if I don't do that. Okay. So you guys remember what we did? Okay. Well, let's try another problem. I think we were to this one right here, example 6. Expand x minus 1 to the 4th. Okay. X minus 1 to the 4th. All right. Well, let's see here. What row of the triangle will I look at? The 4th. Okay. So I'm going to come back over here. I'm looking at the 4th row. So this guy right here. So my coefficients are going to be 1, 4, 6, 4, 1. Okay. So I'm going to come over here. 1, 4, 6, 4, 1. Okay. Now, the only difference here is that instead of a and b, my terms are x and negative 1. But I'm still going to write them out the same way. For each of these 5, I'm going to go ahead and put x and then a negative 1. X, negative 1, x, negative 1. I'm going to go ahead and label my terms here. I didn't put that, I don't know why I put that one in parentheses. X, negative 1. Just like I did a moment ago with a and b, just whatever the terms happen to be. Now the first term, x, always counts down. But here, what's the first power I'm going to place on it? So I'm going to say 4, 3, 2, 1, 0. The first term's power decreases. The second term's power increases. So I always start it with 0, 1, 4. There we go. Now it's just a matter of simplifying each one of these. Okay. Well, you said negative 1 to the 0. Anything to the 0 is 1. So 1 times x to the 4th times 1. X to the 4th. Okay. Now it looks like I've got 4 times x cubed. What's negative 1 to the 1st? That's just negative 1. So what would I put here? 4x cubed, positive or negative? Minus. Okay. So I've taken care of this first one. I've taken care of this second one. And then we just go right along. What's going to happen to a negative 1, though, if I have an even power? It's always going to be positive. So what's my next term? 6x squared. Okay. And if negative 1 has a odd power, that's when it's negative. Remember, if you were subtracting in the binomial, it was going to go plus, minus, plus, minus. It was always going to alternate. In fact, minus what? 4x. And this last one would be a plus because the negative 1 has an even power. Just plus 1. That's it. And there you go. Is there anybody who's not sure how I got any of those terms? Anybody confused? Okay. Let's try another one. What about x plus 2 to the 5th? Okay, so what row am I going to look at? Okay, so the 5th row. So that one is 1, 5, 10, 10, 5, 1. Yeah, remember, always start with 0 and then count. Okay, so 1, 5, 10, 10, 5, 1. So I'm going to come back over here. So 1, 10, sorry, 1, 5, 10, 10, 5, 1. Okay. So my two terms this time, the first one is x. What's the second one? 2. So I'm going to say x times 2, x times 2, x times 2. Each term is going to have its own combination of x and 2. Those are what I'm expanding. Just like before when I did a and b, just like before when I did x and 1. Okay, x and 2, x and 2. Okay. And it's always the same rule. The first term, its power does what? Goes down. So I'm going to start it with what, though? Start it with the term I want. So 5, 4, and then 0. The second term, I count up, starting at 0. So 0, 1, 2, 3, 4, and 5. These are all going to be plus because we do not have a negative here. Okay. So let's see. 1 times x to the 5th times 1. So that's x to the 5th. That takes care of that one. Plus. Now here's where we got to be careful. You actually have a base that's a number. So this is 5 times x to the 4th times 2. So that'd be 10 x to the 4th. Is everybody okay where I got the 10 from? Okay. Now this next one is really 10 times x cubed times what's 2 squared? 4.
So 40x.
So that would be 40x cubed. Everybody okay with what I'm doing? So what would the next term be?
It would be no.
Ooh, a little higher.
80.
80. Because this is really 10 times x squared. 2 cubed is 8. So that would be 80x squared. What's 2 to the 4th? So this is 5 times x times 16?
So it would be, so 16 times 5, right?
Yes.
5, 10, 15, 20, so it would be 50 plus another 6 is 30, right? 80.
80x. There we go. And then 1 times 2 to the 5th. Well, all we need is 2 to the 5th. 32. There you go. That's it. Okay. Again, remember, it makes it so much easier to expand these instead of the old-fashioned way where you'd have to say x plus 2, x plus 2, x plus 2, x plus 2, x plus 2. I mean, can you imagine if you're trying to do one of those like to the 10th or the 11th? Okay. That would take a long time if you're doing it by hand, but this drastically cuts down the time and the amount of work you have to do. Okay. Let's try this next one. 2x plus 5 cubed. Okay. So cubed means third row. Coming back to my triangle. So 1, 3, 3, 1. Would everybody agree? Okay. So I'm going to come back over here. So 1, 3, 3, 1. I took the fourth row coefficients. Or excuse me, third row coefficients. I'm sorry. Sorry. Okay. Now, what are my two terms this time? 2x and 5. So each of these will get a 2x and a 5. 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 Sorry, I got a little caught up into it. Okay. What do I do now?
Now you would do the countdown and count 0.
So which one's countdown?
The first one.
Okay.
So that would count down from
3, 2, and then 0, 1, 2, 3. Are all of my signs positive, or are they going to be positive, negative, positive, negative?
Positive.
All positive. It only alternates if you're subtracting. So I know all of these are going to be pluses. Okay. Any questions on how I set up the terms? How are we doing? Okay. All right. Well, then, somebody help me out with the first one.
2x cubed.
So what is, well, now be careful. It's the quantity 2x cubed. So really this is 2x times 2x times 2x.
Oh.
Oh, that would be 8x cubed. See, because the first term is a product, so we're going to be raising the power to the whole thing. So 2 cubed and x cubed.
Oh, okay.
Okay.
Times 6, 4 times 2.
There we go. So there you go. So what would quantity 2x squared be? So that'd be 3 times 4x squared, but then we also have that 5 there. So that would be 60x squared. Boom. Okay. Do you guys want to try to figure out the other two on your own?
Yeah.
Okay, don't say them out loud. Let me give you about 45 seconds. 45 minutes? Oh, I wish. Do, 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 do. You thought I was going to say what? Oh. Why would that scare you?
Because we're running out of time.
Oh.
You should do that in here like one day. You really should.
Do the Jeopardy thing song?
Yeah, honestly.
That'd be pretty cool.
Yeah. I like Jeopardy.
Okay. All right, so somebody help me out. What would the third term be? That is exactly right. Because you've got 3 times 2x. It was just to the first power. 5 squared is 25. So 3 times 2 times 25, 150x. Yes. Now this last one here, what would 2x to the 0 be? It's still 1. So 1 times 1 times 5 cubed is 125. There you go. How we doing? Anybody having trouble? Okay. All right. There is only one more part of this lesson that I need to show you, but I'm going to go ahead and stop there because it's been a very long week. Unless you guys want to keep going. Are you sure? Because I'm hearing a lot of yellows do it.
Yeah, let's do it.
All right. So we will stop there.